Okay, can you see my screen?
It's loading. Yeah, I
Okay,
can
it's
see it
loading.
now.
Right? Okay, good. Okay, so I think this was the first one.
Yeah.
Um, the one that had the definition of the sequence. Okay, so let's look at what we have here. This is just the basic explanation, right? And the first thing that looks like a sample here is that 27, 9, 3, 1, and so on and so forth. So
Yeah.
if you look at it carefully now, it looks like the numbers are getting smaller. But if you look at them carefully again, there's a pattern, and that pattern is simply one of, if you look at it again, it's actually one of multiplication. Now, somebody
Mm.
will say multiplication by what? So that is what we want to figure out now. Any term divided by the previous term. So in this case, any term would start from the second term, and that's 9. So 9 divided by 27. That's why you have 9 over 27, or 3 over 9, or 1 over 3. And if you check each of them, you will see that each of them they are equal to 1 over 3. So in this case, the common ratio is 1 over 3. So the good thing that you can do is that once you establish what the common ratio is, you know what the first term is. I mean, that's basically all you need to tell us what the end term would be. So, but this question is not after the end term. We just said find A and R. That's the common ratio in the following. Okay. So, um, um, the general formula for geometric sequence is what? Geometric, yeah, sequence is what you have down there. AR raised to power n minus 1. Okay. So, everything on this page, at least you have a good understanding of it, right?
Yes, sir.
Okay, good. So let's move on to the next page. I just want us to go through this before we start looking at the question. Then, let me see. I don't know if I can. Why this thing is blocking me? Okay, good. It's no more blocking me. Okay,
Oh yeah,
so
I think the she meant the nth term. She was
the
I don't know, she was doing gaps,
okay,
so it was a
o-
bit confusing, but I think she said find the nth term and find the I don't know, but I think
and find them. Okay, okay, okay. Yeah. So that's the only thing it could have been. Find the nth term and find the tenth term and the number of terms in the sequence. Okay, so let's see what the end term is is going to be. That um, let me see if I can work it. Hold on. Um, I need to share my full screen. Uh, okay, all right. So I'm sharing my full
oh
screen
yeah,
now.
she meant
Right,
the number of terms in the sequence
the
for
number.
the gaps.
Okay,
Yeah,
yes.
for the gaps.
Okay, okay. Okay, so of course, the whole idea is that if you can find what the last term is, right? A term that has a sequence that has 51 terms, just for as an example, the 51st term, right, is the
Yeah.
last term. That would tell us that there are 51 terms in that sequence, isn't it?
Yes, sir.
So that's just the concept behind this one. So So now the aspect of finding the end stem, do you understand that bit?
Is it this place?
the side that has the A equals to R
Yeah,
equals, you understand that bit?
yeah, the previous and the yeah, I know
Okay,
that.
okay, okay. And then, of course, I think what she just did next was to substitute it into the formula. A times R raised to power minus 1. And then, even though the thing is not looking complete, sha, but,
Yeah, I
uh,
don't know why she did that, bro.
okay, okay. Anyway, let me see if I can complete this.
I want to try
This.
to reload it. It's not working.
Okay, okay. No, don't worry, don't worry. Let me just. But you can still see my screen, right?
Yes, I can.
Okay, okay. So R is equal to, based on the question, 6/2. That's the second term over the first term, and 6/2 is equal to 3, right?
Yeah.
So the nth term of that geometric sequence is given by Tn equals, um, A R. That dot is multiplication, so maybe we can just put it, raised to power n minus 1. Okay, so if we just substitute the things we have, right, that will be, uh, 2 times A raised to the power of n minus 1. Okay, so
Okay.
this is the nth term. So this how it should look. Okay, so the next thing that, um, um, we see is what is the tenth term. So the tenth term would be where n is equal to 10. Okay, so let's see how that was obtained. So that would be T10 would be equal to, uh, 2 times, uh, 3 raised to the power of 10 minus 1. Okay, so, 10 minus
Okay.
1, that's 9. 3 raised to power 9. What would I give you? Uh,
Uh,
2 times 3 raised to power 9.
that's 39,366.
39,366.
Yeah.
Okay, okay, okay. That's without multiplying it by 2. Did you also,
No, all together.
okay. You said 39,000,
Three
yeah,
to nine
39.
is 19,683
Okay, okay. So when you now, is it
multiplied by two.
236 or 266? 39,000,
366.
oh, 366. Okay, okay. 366. Okay, all right. So that's the 10th term. Okay, so, let's see. The other part, I think that other part may be a bit challenging to understand. The one that says the number of terms in the sequence. Okay, so remember, if we can find out what position is the last term, then automatically we know how many times there are in the sequence. Okay, so uh, the idea now is that Cn is equal to that 1,458. Okay, 1,458. Okay, so let me see. Let me just be sure. Okay, yes, I got it. Okay, so now the thing is this, right? We know that Cn is also given by the what do you call it? This general formula, which for this particular sequence is this one,
Yes.
right? The one I'm putting
Yeah.
in the box now. Okay.
Yes, sir.
So the the what I can say basically now is that I can now say that one okay, we can do it anyhow we want to do it. Either you say that 1,458 is equal to um 2 times 3 raised to power n minus 1. So our job right now is to find n. So now because this is multiplication, right? So maybe we need because sometimes that can now start looking like decimal points when it's not. So what we now need to do is we can take care of this two by dividing both sides by 2, and that would leave us with 2 out on this side. And if we divide here by 2, what do we have? Um, 2 and
Mhm.
14 is 7, right?
Yeah, that's 729.
729, okay, 9, okay, alright, yeah, because of the 18. Okay, so what we have now is 729, okay, being equal to 3 raised to power n. Now, the idea is for us to express 729 as a power of 3 so that we can compare it to 3 raised to the power of n minus 1. So I think that was the next step where we have at 729 is 3 raised to power 6. Okay, okay. And because of the fact that they have the same base, the only implication is that n minus 1 must be equal to 6. And that's where we now have, can now say, therefore, you can say 6 equals n minus 1. And that will mean that for us to get n, what would we need to do?
We have to bring it over into
Yes,
sign.
exactly, to the left hand side. So that would be 6 plus 1, which is 7. Okay, so this bit, you understand it, right?
Yes, I understand the part.
Okay, all right. So let's take on, maybe we should just take on one of the questions. Um, okay, so let's take on that first question, right? What's that? Let me check. I need to go back to my notes. Okay. The first question. Okay, that's it. You can still see my screen, right?
Yes, I can see it.
Okay, good. Okay, so it says that the nth term of a geometric sequence is given by this. Okay, so this one, they gave us what the nth term is, even though it's looking slightly, uh, well, yeah. Yes, well, it's not looking like the typical thing. That's n minus 5, right? Or n minus 8. 12 times 4 raised to
N
the power of
minus 8.
8. Okay, good. Okay, so the question is find C1. In other words, that's the first term. Find C1, the first term, and R, the common ratio. Oh, interesting. Okay, so you know what we're going to do? Uh, let me go to my, let me see. So let's represent the question first. Number 6. Okay. The question is what again? It tells us that Cn is equal to 12. mm, I think I even like this representation that put this thing in bracket 4. Now, do you know what? We can't, um, um, had it been what we have outside the bracket for that 4, where n minus 1, we could have just straight away concluded that the first term is 12, right?
Yeah.
Yes. Had it been this 8, we are 1, but it's not. So we can't just conclude that. So we have to figure out what the first term is. Now, meanwhile, we know that the general Tn for any geometric sequence, at least, right? They told us that it's a geometric sequence. Good. The general term for any geometric sequence is equal to what?
A and R.
Yeah. And then minus 1,
Raised to
is it?
power N minus 1.
Minus 1. Good. So the first thing we're going to do is to see how, let's put it, let's put them, let's put them side by side. A, R, and minus 1 equals 12, 4 raised to power n minus 8. Okay. Okay. So, ah, okay. So let me see. So the key thing we can do here. How can we make the right hand side look like the left hand side? So this is what I'm going to do. Minus 8 is as good as minus 1 minus 7, right? Do you agree with me on
Yes.
that?
Yes.
Okay, so that's going to be 4. Then let me see if there's another way. Okay, no, let's see. Let me just continue that way. Um, that will be n minus 1. Uh,
I was thinking instead of
okay, yes,
uh
yes. Yes, let's interpret what that minus is. That minus is the same thing as this, right? Let's just interpret it like this. Then we will now um our aim is to get to the minus 1 bit, and this can still be written as um 4 um okay, so 4 to power 7 Okay. So this is what I want to achieve, right? The 12 is on its own, multiplying that, yeah, and then 4 raised to power 7 is down here. So what um um I want to be able to achieve is this. Uh, 12 over 4 raised to power 7 times. I can now take this other one back to 4 raised to power n minus 1. Okay. Now, of course, I'm still going to break this guy down. The 4 raised to power 7. Um, because of the 12. So one of the fours down there can take out 12.
Oh, I think the question said we should find T1, but they were
Yes, the
just
first.
giving, yeah, because I was thinking instead of it to be Tn, we should use sub it in as T1, because the first, if we go back to the question, it says for us to find the T1, the first term, and R, the common ratio.
Okay, the first term, right?
Yes.
Okay, okay. Okay, okay. So just substitute for n, where n is 1. Okay, let me see. If we do that, let's see what we'll have. 12 uh, for, okay, 1 minus 8. Okay, I think, okay, it's anyway, yeah, it's still the same thing. Mm. Uh, for, okay, so if I were to take this one step further, right,
Yeah.
so that it's not like we want to, you know, because I know that, the 12, something can still work on that 12. Beneath here, I have 4 times 4 raised to power of 6. And so that will leave me with 4 here, 1, and 4 here, 3. Okay, so that would be 3 over 4 raised to power 6 is what?
Mm, 4 raised to power
Evaluate
6.
it.
That's 4096.
4096, right?
Yes.
Okay. Uh, oh, okay. So it's okay for us to leave our first term like this, Abi?
Yes.
Okay, that's fine. Okay. Anyway, I think I would have still arrived, or somehow I would have arrived at it, somewhere, somehow. Okay. So the common ratio, what's the common ratio? What's the common ratio? Okay. So, um, if this is the T1, then hmm, okay. So what do you think we should do to get the common ratio? Do we need to find T2? We could, and then say T2 over T1. I'm just thinking, would that be an overkill of some sort? You know what? Based on what I did back here, right? If you look at the left hand side, if you look at that left hand side carefully, and you see that A, I've already gotten A somehow from that from this side where I'm writing now,
Yeah.
and R being n raised to power n minus one. Based on that, A is this, right? Can you see that?
Okay.
The one I put a box around. A is this. So that means obviously R will be this. But now I'm not sure whether you understood how I got that 4 raised to power n minus 1. Do you understand how I got it?
Mm, I don't understand.
Okay. So you know what we'll do? Leave what I did on the left hand side. Let's do T2. Let's
But
just
what?
do T.
Why are we doing
Yeah.
T2?
Okay. Okay. So the thing is, um, it's so that we'll be able to find the common ratio. Or okay, no, don't worry. I think I can find a way around it. I can find a way around it without we may not need to do T2. So um, so we've already concluded that T1. T1 is that um, three. Okay. Okay. So this is the thing. If I need to get the common ratio, I'll need to know at least two terms. Do you understand what I'm saying?
Yeah.
So for now, the only term I know is T1, right? So for me to get um, the common ratio, right, at least one way is to say T2 over T1. Do you understand why it's like we need to do T2?
Okay.
Uh, so okay, so let's just do that. This is, let me write that better. So T2, based on what we have here, T2 will be equal to 12 and 2 minus 4, and then 2 minus 8. Yeah? And
Yes.
2 minus 8 is minus 6, right?
Yes.
That would be 12 over 4 raised to power 6. Okay, and that would further be, if I want to do it the same way I did, what do you call it, the T1, I can split that 6 into 4 times 4 I have um so that's my five is not looking like a five. Okay, so that will now be 4 and 12. That's three, right?
Yeah.
So that would be uh three
3
over
over 1024.
1024. Okay, okay.
Yeah.
So now you can now figure out what R will be. R will be let's just quickly do this because of space. R will be C2 over C1, isn't it? C2 divided by C1. Let's just say divided by C1. And that should give us what? 3
11
over
1000.
1024. Uh, you know what will
Divided.
happen now? Yeah. Would we could turn the division into multiplication at once, or do you want us to take it step by step?
I was thinking we should divide all of
Yes,
them
yes,
together.
yes, we will. Okay, okay. 3 over 4096, right?
Yes, sir.
Yes. Okay. So since it's a fraction, we're going to flip the one on the right hand side. So that will be 31024 uh, times 4096 over 2. So what did you notice? 4096 and 3 will cancel itself, right? And if you divide 4096 by 1024, what do you notice? You
It's
should
giving
have
me 4.
4 exactly. So you see that that's what I want. That's what I was trying to explain to you on that left hand side. But I understand that you might not really get that method. So that's why I switched to this other method.
Okay.
So yes, anyone that you understand should work. So that's fine. That's what R will be. So you are good with this, right?
Yes, sir.
Okay. All right. So let's go back to the question and see what's left of it. What's next bit? It says
7.
find the sum of the first 13 terms. So that one is first 13 terms. That one is series, right? Wait, since that one has to do with sum of terms. Okay. So did you guys talk about sum of terms? Sn.
Some of wait, let me check. We
Yeah.
did
Yeah, I think
uh,
that yes. You said you guys did series now, have you?
yes.
So
I
that
think I
series,
sent part of the series to you.
yes, you did. You did. So it's the formula that I just need now. Let me see. I think I have it here. Okay, geometric series. So where um the common ratio is bigger than one, right? the R will be on the left hand side, and where it is smaller than one, it will be on the right hand side. Okay, so yes, I think this is what we'll work with. Sn, you can still see my screen, right?
Yes, sir.
Sn equals a into bracket 1 minus r raised to power n. Okay, so um we are going to slightly, this one will slightly change because our common ratio here is bigger than 1. Okay, so mm, this one requires some patience, right? Well, let's see, I think we can do it. So Sn will be equal to, the formula we use for this one is a into bracket r raised to n minus 1 over r minus 1. Okay, alright, so here we go. S13. I think they said first 13 times, right?
Yes, sir.
So that's going to be, the first term is what? So 3 over 4096. So that's going to be 3 over 4096. Okay. And then in the bracket there, right, is going to be 4 raised to the power of um 13 minus 1. Okay. And then all this will be divided by 4 minus 1, which is 3. Okay, so I think you have your calculator there, right?
Yes, I do, sir.
Okay, all right. So maybe you help us to this one. What do you have?
Okay. Um, give me a second, sir. Okay. I'm getting 16383.99976.
Is it giving you like exponential stuff?
Yes.
Raised to a particular power, B.
Not
Okay.
raised to a particular
Mm,
part. It's just giving it's giving 16,383 point 999.76.
okay. Wait, let me see. Okay, let me be sure of the difference. Number of times in sequence. Let's see. So, this is basically, so the reason why this one is the other way around, like 1 minus r raised to power n, is because of the, um, is because the common ratio is less than 1. Okay, so let me see. I don't know why. So that number that you gave me now is just 4 raised to power 13, right?
Uh, is it?
The number that you read out now.
Oh yeah, it was I divided three
Oh, okay.
over. I divided the whole solution. The
Oh,
second one, that's how I got the answer.
okay. That's why it's giving that decimal point. Okay.
Yeah.
Ah, okay. I was thinking that maybe you give me
No,
the
I think
forest. Like,
I think she said something like you have to when it gets to the where your arrow is pointing, when it gets to that solution, you just have to put
mhm.
it in calculator to get the answer.
Okay. Okay. So you've done everything. Is that what you just did?
Yes.
Okay. All right. Okay, that's fine. So let me. So do you want to confirm if that's the same answer that is there in the book?
Is it for the textbook? Oh, let me check the textbook.
Uh, but sorry, give me the number again. Let me write it down.
Um,
Mm-hmm.
16833
383. Okay.
point
Yeah. Point
999
two nine.
and seventy
Okay.
six.
And 76, right?
Yes, sir.
Oh, okay. Oh, one, one, two, three. Okay. Okay. So let's just confirm if it's
Yeah, I want to check the textbook, please.
okay.
Number 7.
Is it number 6 or number 7 you're checking?
Oh, number 6, sorry.
It's number 6, yeah. Number 7 is different.
Number 6. The second one is given
Okay.
16,384. Oh, I think you have to
You round it up.
round it up, yes.
Okay, that's fine. Okay, at least it shows that we're on the right path.
Yeah.
Okay. So so I don't know if it was an omission on her part, but um the notes your teacher gave you, right, on six series, yes. So this example, if you notice, this example that she gave, the common ratio is 2/3. And if you know 2/3 as a fraction is less than 1. So
Yeah.
anytime the common ratio is less than 1, this formula that we have here, the Sn a into bracket 1 minus r raised to power n over 1 minus r applies. But if it's the other way around, where, like in our own case, the common ratio is 4, and 4 is clearly bigger than 1, um, you just move things around. The r raised to power n will be on the left hand side, while the 1 will be on the right hand side. And in the denominator, r will be on the left and 1 will be on the right. Okay. Now, do you know what
Mhm.
will happen if you don't flip it like that? When you have um, a common ratio that is bigger than 1, do you know what will happen?
Uh, you
Okay.
want to, I don't understand.
Yes, go ahead.
I don't know.
Okay. So if you look at that denominator very well,
Yeah.
imagine that you had 1 minus 4. You notice that you will have negative, you will have minus 3, and that will
Yeah.
make everything, it will make it all, it will make everything negative somehow. So, so, um, but then ideally, just, just understand what I just said now, that the common ratio, the sum of the first n term in of a geometric sequence depends on depends largely on whether the common ratio is greater than 1 or less than 1. Okay. Once you have that at the
Yeah.
back of your mind, you will know which formula to use.
Okay.
All right. So let's go to now. Look at this number 7. Do you think after doing number 6, does it feel simpler? Just take a look at it. Does it look simpler? The first two terms of a geometric series are
When they say
200.
find the common ratio, is it
Common. Yes, yes, go ahead. Yes.
is it the like when they say the common ratio, what does it actually mean?
The number, remember, common ratio is that any term over the previous term.
Oh yeah. Okay, so
You
that's
remember it?
that would be
Yes.
216 over 54.
Not that. Now look at that. See, so let's read the question. The question said the first two terms. So we're expecting that the arrangement is 216 coming before 54. Did you get that?
Yeah.
So that means it's actually the other way around.
Okay.
54 over 216.
Okay. And
So
then the second one said find the
the
sum of the first six terms,
sum of the first six,
sum of the
correct, to two
first.
place. Mm. Okay, let's do it. But at least you are getting the gist of it, right?
Yes, I am.
At least, yeah. Okay. So let me see. Do we have enough space here to do number 7? No. Let me just save this and open a new one. Okay. What's today's date? Is, Uh, uh, let me not to save it the date. What is this? Okay. Um, all right. So let me just open a new one. Mm. Okay. So was in number 7 now.
Okay.
Okay. So maybe after this, I'll send you. I could send you this file, right? The images, if you want
Okay.
to have them. Okay. All right. So let's take a look at number 7. We've already concluded that the common ratio, number 7A, common ratio is what was that again? 54 over 216. Okay. So this one, well, I guess, what number will break this guy down? 9. Would 9 work on this? Or 6? 6 will do this, right?
Yeah. Uh,
Which number would you prefer to use to break it down?
I think now is okay.
9? Okay,
Yeah.
let's do 9. Yes, let's do 9. Yes, 9 is better. 9 in 54 is 6. Um, 9 in 21 is 2. Remember that's 3. And that's 9 times 4 is 26. So that's 4. And then finally, 6 in here 1, 6 in 24 is 4. So the common ratio is 1 over 4. So therefore R is equal to 1 over 4. You got that right?
Why are we using 9?
Okay, so that we have options. We have
Yeah.
options to use to break it down. We could use 6,
Oh, okay,
but
okay, okay, I get.
use 9 because it will make us faster. Do you understand?
Okay, I get.
Yeah. Okay. All right. So that's for the A part. The
Yeah.
B part. Um, let's look at the B part. What does the B part do? Or the two Roman numeral two. It says find the sum of the first six terms correct to two decimal places. So you by now you know what the formula would be. S6. Okay, now let's do Sn first. They will now put in the details.
A
A,
bracket
yeah. Now,
1
can
minus
you tell
1.
me which one we will use? Which one should come first in this one? Is it
Mm,
the 1 or Rn? Which one do you think should come first?
1.
Exactly, it's 1. You know why 1 should come first? Because in this case, the common ratio is less than 1.
Okay.
Yeah. So, raised to power n. And if you are wondering, how I know it's less than 1, just look at the fact that 1 is dividing 4 or is being divided by 4. I mean, once you see 1 over 4, you know that its value is less than 1 already. So
Okay.
yeah. So S6, right, is the first six terms that they ask for, will give us 216 is the first one, according to the order of the question. Um, 1 minus. Now, 1 over 4 is 0.25, right? I think since
Mm,
we're just crunching it in calculator, let's just put, can push it to the limit as much as we can. 0.25 raised to the power of 6, um, divided by 1 minus 1 over 4, which is 3 over 4. Yeah, that's it. 3 over 4. Yeah. Okay, so can you handle this? let me even change 3 over 4 to a decimal. Instead of 3 over 4, you can put so that to make your calculation easier. That should be 0.75. Yeah. So when you are doing it in your calculator, you can put 0.75 for the denominator. But of course, you are going to do this 0.25. Okay, so go ahead. What did you get?
okay. So,
And they said it's to two decimal places. Yeah.
mm, all right. Is that 3 over 4?
Which one? The
Okay, sorry.
denominator.
Yeah,
Yes, it's three.
I
But I just pushed it to decimal so that it will make it easier for you.
is 211.296.
211 point what?
296.
Okay, 0.296. So if you change that to decimal places, that would be 0.30, right?
Or I think it would be 211.
Because of the nine,
Uh,
you understand? Because of that
Okay.
9, two decimal places. Do you get the
Okay.
6 will turn 9 into 10 because it's more than 5. So
Okay.
once 9 becomes 10, it will now affect 2. 2 will now become 3. So this is,
Okay.
this is what it will be.
Oh, I
Do you
didn't.
understand?
There is. Oh, it was 0.25 raised to power. Oh, I was thinking it was 0.256. I think I did the calculation wrong.
Yeah. Sorry.
Sorry, let me click.
Raised to power 6. So
I thought it was 6 beside.
no, no. Oh, sorry, my handwriting. No, no, want it to, because I didn't want it to, I didn't want it to be on the sheet.
Oh yeah, it's 287.929.
Come again,
It's
287.99.
9296875. Nine
Okay,
two
29. Mm-hmm.
six eight
Okay, 6, 8,
seven five.
7, 5. Okay,
Mm.
all right. In any case, we will need all these decimal places. Let's focus on this. So we're starting from here because this one is 3 decimal places. This is what will tell us what should happen. So the 9 will make this 2 to become 3, right? And
Yes.
that will leave us with 287.93. Okay, so you're familiar with uh, approximation, right?
Yes, sir.
Rounding up, rounding down, and all that.
Yes, sir.
Okay. All right. So that's it. Okay. So let's go to the next one. What does the next question say? Find the sum of the second six terms. Okay. So the second six terms correct to two decimal places. The first six terms, the
Oh,
second six terms.
second
So the second
system
six terms would be what?
two.
From from the seventh term to the 12th term. Is that it?
Oh, okay, okay.
Do you get it?
Yes, I
From the
got it.
seventh term to the 12th term.
All
Hmm.
right.
Now, do you know how I will do that particular one? I'm
Are
not
you
too
going to
sure.
change 6 to 12
I'll change
or
6 to 12, correct? But at the
yeah.
same time, after getting my answer for S12, you know what I'll do? I'll subtract the S6 from S12.
Oh yeah, okay.
Do you get it now? That's what will
Yeah.
give me from S7 to S12. The sum that second, because it says second six term. So second six term just means the second set of six terms after the first set. So you
Oh,
get it?
okay. Oh, okay. So it's
Yeah.
basically saying you should just
Hmm.
subtract it. Okay.
Exactly. Exactly.
Okay.
Yeah. So um so let me just write it on top here. That S7 to 12, I think. Yeah, that's the next system. Will be equal to S12 minus S6 so that we know what we are doing up front. So we've already gotten S6. So our next job is just to get S12. So let's just quickly put it down and then We'll punch it in the calculator and we're good to go. Okay, so that's still 216. It's still the same sequence, so we're rolling with the same first term. 1 minus same 0.25, but this time it's raised to power what? 12, right?
Yeah.
The 12 really tiny. As tiny as I can. But it still looks like a 12. Okay, now don't forget to put your bracket over the same 0.75. Things don't really change much here. Okay, so can you punch that? Let's see what we get.
I'm getting 287.9999828.
Did you say 287 or 387?
It's 2.
2.
Yes.
Okay. Okay. 287.
0.9999. Like 49.
Wow. Okay, so it's not really the
Difference.
difference is not much like that. Ah, I think
Yeah.
I know why. I think I know why. Because of
Because
the
I think
common
the
root.
second time.
Yeah, you said what?
I was thinking maybe because it's the second system, so it shouldn't be much difference between the first one.
Okay, between the first one and the second one. Yeah.
Yeah.
So I'm even looking at common ratio. That common ratio, whenever common ratios are less than one, it's
Yeah.
stuff like this happens. Um,
828.
you said 8 to 8 comes after the 4 9.
Yes.
Okay. Now, if that 8 to 8, I'm looking at how we can. Okay, so you know what we'll do? 8 to 8, Abby. No problem.
Yeah.
So let's see what we will do. So, um, what we'll do is when we want to do the minusing, right? Because it looks like the 287 and 287 are the same. By the time you minus,
Yeah.
that side will be zero. The only side that will not be zero now will be the part that's after the decimal point. So what we're going to do is we're going to be using uh, this one minus this one. That's before we approximate it. Do you understand?
Okay.
So let's do that. If not, the whole thing will just come up to almost zero. If not, we don't do it like that. So let me write it. S7 that's the next 6 7, 8, 9, 10, 11, 12. Correct. Yes. 16. The next 7, 10. The next 6, 10. Sorry. So that will be equal to S12. Okay. So have you been able to subtract it? What did you get?
Uh. Okay. So I should subtract it by the.
Yes. This number that you got now, right?
Yes.
Minus this got for
Okay.
S2.
Okay.
I know it's going to give you 0 point something. That one is obvious. It's just 0 point what?
Zero point 0.070295333386.
Okay.
But basically
0.07. Yeah.
zero
Mm-hmm.
295
Okay. 29. Okay.
295
Uh-huh.
triple three.
They put 3. Okay. That one I just, let's just forget about the 3 that comes
Yeah.
after. Not cannot change. the numbers in front of them. Okay, now the question said to two decimal places. So that will leave us with just 0.07, isn't it?
Yes.
Means nothing can change the 7 that's behind it. Nothing. So yeah. Okay. These answers are looking funny, but yeah, I think the book validates what we're doing. I'm sure we're on the right path. But I'm not surprised. Whenever common ratios are less than one, this is what happens. The things will keep on reducing, they'll keep on getting smaller and smaller and smaller. Okay. So do you want to check if we're in terms in, on the same path with the book?
Yes. Wait, let me check.
Okay. Alright.
It says 0.06.
0.06
Yes.
for the one we just did.
For the last one that we thought 0.07, but it was 6 years.
Yeah.
Maybe
Okay,
it was
okay,
the
okay.
round. Maybe the rounding up.
The rounding up, yeah.
Yeah.
Anyway, I think we're close. How about the other one? The 287 thing.
Point nine
The one
three. Yes.
was correct. Okay, good.
Yeah.
Okay, that's fine. Okay. Okay, so do you want to go with the rounding up?
Yeah, I just feel like is maybe
Uh, so
the way the book
mm,
rounded it up,
arrive
because they might be using a different calculator.
to, so what I'm going to do is let's round up this one then. But usually, what I know about questions like this, whenever questions involve decimal points that have high precisions like 7 decimal places like this one, huh, it usually advised not to round up or use rounded up values until you get to the final answer. That was the
Oh,
reason why I
okay.
said that I advise to. But let's see if when we round up and subtract, whether we're going to get what the book got. So if I round up this S12, right,
Mhm.
nine has already messed everything up. So it's going to make that 999 to be, it's
That'll be
going to
two
make
eight.
it, um, it should become 288, isn't it?
Yes, sir.
So it's going to be 288. Okay, point zero. Okay, so can you see? It's even, it makes it, um, so if you now subtract, okay, let's try it now.
I'm getting
Two eight
0.07.
really, even with the
Yeah.
288 minus
Yes.
287.93.
Yes, the
Uh,
same answer.
so
I feel like it's
anyway,
the way they calculated their own. Because
yeah,
we use different calculators, so the rounding up used to be different. But I think during the exam, they understand the fact that we use different calculators, so
okay,
they either
okay,
say that it's either a 0.06 or 0.07.
okay, 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 that's fine. Okay, all right. So, okay, so can I go on to the next one?
Yes, sir.
I think so I'll send you this in case I know you may want to write it down. Number 8, I
I've
think.
screenshotted it.
Oh, yeah, 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 yeah. You did. Okay, yes. It was among those ones that you sent to me. Oh, okay. You screenshot what I wrote down, right?
Yes, sir.
Okay, okay, that's fine. Okay, that's good. Okay, so let's go to number 8. Three terms x, y, x, comma, y, and x plus y are in arithmetic sequence, and x is not equal to 0. Okay, those are conditions they told us. What's next? It says three terms x, y, and xy are in geometric sequence. Okay, so what's the question here? um, find the value of x and the value of y. Okay. And then it now says find the difference between the sum of the first eight terms mm, of the arithmetic sequence and the sum of the first eight terms of the geometric sequence. Wow, that's a really interesting question. Okay, so let's look at the question again. Eight terms, this, and this, and arithmetic sequence. Okay, nice. All right, so let's see if we can make some decisions on that. The first one is says in arithmetic sequence x. Let me just put
Yes.
A here. Okay, let me say AS. AS stands for arithmetic sequence, right? If we understand it like that, x, x should must look like an x, y, and then x plus y. They say that they are in arithmetic sequence. Okay, so now if these are in arithmetic sequence, right? Mm.
Mm.
Okay, don't worry, we'll come to some conclusions, but let me write the other one. Geometric sequence, right,
Yeah.
says what's geometric sequence on? X, Y, and XY. X, comma, Y. Hmm. And then X, Y. Okay, so so you know the rules about arithmetic sequence and geometric sequence, right?
Yes, sir.
So let's quickly make our decisions based on that. For AS, arithmetic sequence, the main rule, which is that of common difference, right? For AS, says that y second term minus first term. So these are our own conclusions. So must be equal to third term minus, this is the third term, which is x plus y, minus second term, which is y. Okay, so you agree with what I'm doing, right? You understand what I'm doing, right? Goodness, are you there?
Yes, sir. Yes, sir. Sorry.
Okay, do you understand what I just wrote down there now? Now,
Yes, sir.
okay. All right. So, if I were to simplify this, the y has taken itself out, and that will leave me with that's on the right hand side, y minus x equals x, and then if I now move the minus x to the right hand side, we can safely conclude that y equals x plus x, which is 2x. Okay,
Okay, sir.
so, all right. So let's now go to the geometric sequence. The good thing is that these things are helping us to take themselves out as much as we can. For the GS, the geometric sequence is common ratio, and common ratio is division. So, um, second term over the first term must be equal to third term second term. Okay.
Okay.
So what do you think will happen? The y will take itself out, right? Y
Yes.
will cancel itself, leaving us with y over x equals x. And of course, you can quickly make another decision to multiply both sides by x. So we now have it that y will be equal to x squared. Okay, so now we have come to two safe conclusions, one from the AS and one from the GS, that's geometric sequence, and both of them are y, funny enough. So we can safely conclude that from equation 1, can call this one equation 1, and equation 2, both of them are y. So it's safe to conclude that therefore 2x is equal to x squared. Okay, do you understand it up to this point?
Yes, sir.
Okay. So now that we've concluded that, um, so let me just say the reason is from 1 and 2. So we can write it there. From equation 1 and 2. Okay, so let's move on now. Now that we can conclude that x squared equals to x, we can come up with a quadratic equation. So that quadratic equation will be that x squared, let me say that we continue here. X 2x equals x squared. Okay, so still the quadratic equation that will form. I'll move 2x to this side, so it will become x squared minus 2x equals 0. Okay, so you think can you solve this quadratic equation?
Yeah, wait, sorry. You know, when you said y over x equals to x, why is it y? How did it turn to x squared?
Okay, so you know how you know how when you have okay, maybe I should have left that over 1. How when you have things like this, right?
Yeah.
You can do cross multiply or stuff. Okay. So if
Okay.
you want to say cross multiply both sides, you can, I mean cross multiply, you will still get the same answer. But what I did was just to make the y subject of the formula. So it would mean multiply both sides by x. So the x will cancel itself on the left hand side. And since you have x already on the right hand side, it will become x squared.
Okay.
You get it now, right?
Yes, I get it.
Oh,
Thank you.
okay. You're welcome. Okay, so let's go back to our quadratic equation. So now, how do we solve the quadratic equation? Basically, we could factorize the x, right? So factorizing the x would mean bringing one of the x out, opening a bracket, and leaving us with 1x inside minus 2 um, is still equal to 0, right? So,
Yes.
so the basic principle of every quadratic equation is that whenever you have something equal to 0, you say either x equals 0, and meanwhile, You remember that the question had already told us that x cannot be equal to 0. So that means this case is out. I don't know how else to say it. Excluded or something. I don't
Yes,
know,
sir.
but you understand what I'm saying? It's
Yes,
out
sir.
because it said x is not equal to 0. So we just can put that in a box. Or the second bit is that x minus 2,
Minus 2.
yeah,
Okay.
will be equal to 0. So that will leave us with
X
x
equals to 2.
2. So therefore x is 2. And if x is 2, I'm sure you know that we can equally get what y is from either
No, equals
equation
to 2.
1.
Yeah.
Yeah. So, all right. So y will be 4, isn't
Yeah.
it? Either, yeah. So therefore y is 4 in both cases. Okay. So I think that all that the question asked for. Maybe we should find
Yeah.
x and y. Okay. So that second one, can you do it by yourself? Can you do that second one yourself? Find the difference between the sum of the first 8 terms of the arithmetic sequence and the sum of the first 8 terms of the geometric sequence. Can you do it?
You can do it.
Okay,
So
okay,
we
don't worry. Let's just, you want to try it? Or let's do it
find
together.
it. Okay.
Okay. So first 8 terms, right? First 8. Let's have that at the back of our mind. First 8. So before you can find the sum, you have to get the terms themselves. But the good thing is that we can generate the terms since um, we know what the numbers are. Okay, so go back to your, this place here and here. You already know that x is 2, right? So for the
Yes.
AS, I'll put them side by side. So it will be easy for, it's going to be 2, y is 4. Remember, it's an arithmetic sequence. So it looks
Yeah.
like it even gives itself away. It's even numbers, isn't it? So that's 2, 4, 6, 8, 10, 12, and what else? 1, 2, 3, 4, 5, 6, 7, 8. Okay. So I think we may still need a calculator for this, but anyway, let's keep that first. Then for the geometric sequence, right? Geometric
Yeah.
is multiplying, multiplying, multiplying. So that one is going to be a bit different. So 2, you know that 2 times 2 is 4, and 4 times 2 is 8. You can have to be careful with this one. And 8 times 2 is 16. 16 times 2 is 32. That's 2 raised to the power of 5. 32 times 2 is 64. 64 times 2 is 128. 128 times 2 is 256. Hope I've not passed that. 256. Okay. Let me count. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 9. Okay. So do you understand how I got up to this point?
Okay, because okay, now I understand.
You understand, have you?
Yes.
We are multiplying by 2 because it's geometric sequence. The other one
Because
is
yes,
uh, yeah.
arithmetic, yes.
Okay. All right. So the question is for us to do this. So you can, you know, we can do. quickly use your calculator and add this one up, and then keep the answer, and then we'll add this one up and keep, and then subtract. It's just asking us for the difference.
Okay.
For the first first eight terms of this one and the first eight terms of the second one. Okay. Have you been able to arrive at the answer?
No, not yet.
Okay.
Wait, what did you say I should do to it again? Maybe I'm doing the wrong thing.
No, you're not now. You just
Okay.
add 2 plus
Okay.
4 plus 8 plus 10 plus 12 plus 14 plus 16. You get the
Okay.
answer. After adding it, then add this one to this one
Okay.
together. Then we'll now subtract this. Obviously, the smaller one will be the
Oh,
arithmetic
the first one
sequence.
is 72.
This one is 72. Okay, good. So
Yeah.
how about the second one?
Minus 510.
510.
Yeah.
Okay.
And that's 582.
Nice. Okay. No, the difference, so it's not the sum.
Okay.
Mm, the difference. The difference between 5, 10,
Okay,
and
the
7.
difference. Okay, okay. Sorry. That's 440.
400 and
40.
okay. 540. Okay, so that's it basically. All right. Okay. So you want to do a screenshot of this? I don't know if you can get
Oh yeah,
everything.
I'll do it.
Where let me see if I can zoom out a bit. So that, uh,
Okay, I'll just question everything like that. Scroll up a bit.
I
Yeah,
should scroll up.
so I can get
Okay.
the eight. No, the for the only the eight.
Oh, okay, 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 okay. Okay. Is it better like this?
Yes, I think you. I'll screenshot it.
Okay. All right. So let's see. Okay. So number 9, right?
Yes.
Mm, find the sum of the finite geometric series. Mm, it's finite. So that means it has an end. Okay. Okay. So if you look at this one, the common ratio, right? What would you say the common ratio is for this particular one?
Uh,
3 times minus 2 is minus 6. 6
yeah.
times minus 6 times minus 2 is minus 12. So the common ratio is minus 6. minus 2, sorry. Let's establish that. The common difference is minus 2. Okay, let me write it out.
Now, is it for the ninth question?
Yes, number 9. Yes.
Okay.
Can you see?
Okay.
That number there is 49,152, right?
Yes, 49, 152, yes.
Okay. So it's safe to say that the common ratio is minus 2. Why? Because that's how the next term was obtained. So once we establish that the A is equal to 3 and R is equal to uh, R is equal to minus 2. Now, in case you are wondering another way you can get the R is to say second term, second term is minus 6 over the first term, which is 3, and minus 6 over 3 is minus 3. Now, do you know that the way this question was presented, one would be wondering, it was presented as a series, right? But once you see that minus there, it's very okay for you to conclude that the second term must have been negative. You understand what I'm trying to say?
Okay.
It's very safe to conclude that it must have been negative because imagine when you add something to another number and the add symbol changes to minus, it only means one thing, that the second number must have been negative. So that's why we can safely conclude this. Now we have concluded this. Remember, when you have what do you call it, a common ratio that's less than one, right? The sum, is that what they're even asking for? Yes, the
Yeah, there's
sum
some.
is by um mm, the sum is going to be given by Sn equals what? A, oh my goodness, my battery is low. Okay, let's see how far we can go. A into 1 minus R into power n. Okay, over 1 minus R. Okay, so yeah, now let's quickly find that out. 49,152 Cn equals to R to power minus 1. Okay, so 49,000. If the thing goes off, don't leave. Oh. I
Okay.
will, yeah, I'll just switch to my other computer. 49,100. You know what I'm trying to do now? I want to
Yes, sir.
find out how many terms there are so that I'll know what to substitute in that Sn. Because right now I
Okay.
don't know what term is that
Oh yeah,
49,152.
the term is, I think the term is term 15. Okay. Let me
Is what?
term 15.
Oh, okay, okay. So they've gotten it. Okay, I didn't even look at that
No,
yet.
I saw it on there. I just did it. Just
Okay,
divided by.
okay. Oh, excellent. Because based on what the question is saying there, yeah. Sorry, how did you get C15?
I was just dividing it to get to the smallest number.
Oh, okay.
But I
What
don't.
do you think
Mm,
that's the best thing about it?
mm, I was just multiplying, multiplying
Yeah,
minus two.
minus
Mm,
two. Okay, 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 okay. Ah, all right. Okay, let's see. I was just thinking of if there's another way one can use to get to the answer. But okay, let me just write it down as how, because this one looks like one of those ones that you did in class. The one that you wanted to find, you know, the position of the number before proceeding. Okay. All right. So okay, so if it is 15, right? Let's just work with it then. If it's 15, then we got S15 will be equal to 3 into 1 minus, I have to be careful with this one, minus 2 raised to the power of 15.
same.
So when you are doing your calculator something, you have to be very, very careful with that guy. That the minus outside cannot, anyway, you can do something with the minus outside because, oh,
Yeah, that would be close.
Okay, goodness. Can you hear me now? Hello, goodness. Are you there? Goodness, can you hear me?
Mm. Hello?
Yes, I can hear you. Can you hear
Okay.
me?
My we want to increase the volume of the speaker, but
Okay,
can't find it.
okay,
Mm.
okay. Let me see if I switch to my AirPod. That will be better too for me so that I can hear you.
Okay.
Yeah. Okay, nice. Good, good. Okay. All right. You can see my screen, right?
Yes, I can.
Okay. So so that laptop has the battery is good. Okay, but can you that's where we were working. Can you finish it yourself?
Yes, I can.
Okay, okay,
I have
awesome.
maths next Monday, so I will do it
Oh,
during the
okay,
weekend.
nice. Okay, good. Okay. Okay, so we should just do the last one, right?
I understand the last one. It's just the 6, 7, 8, and then 9.
Okay, that's 17. Is it something you can do by yourself? Because you didn't send that one.
Oh yeah, I will check and send it to you. If I don't know how to do, I will just send it to you.
Okay, okay.
So we can do it
Uh,
maybe the next lesson.
okay, okay.
Mm.
That would be Saturday. Okay, okay. So you try and work on it before Saturday, right?
Yes, I'll do it for
Okay, that's
Saturday.
good. All right,
I'll
no
try
problem.
send it to you.
Mm-hmm. Yeah,
Okay.
just the way you sent the other one.
Yes, I'll send what I did to you to see if it's
Okay,
correct.
okay, that's fine. Okay,
Mm.
that's fine. All right. I was thinking that maybe you'd have to turn it in before maybe tomorrow or something, but it's fine.
Okay.
All right then. I think
Okay.
okay. So there was something I wanted to tell you. Yeah, I know there are quite a number of questions in each exercise, right? And
Yeah.
you probably have other subjects you also need to um take on and study. But I wanted to suggest that if there are ways, I don't know if you're already doing it. If you're doing it, that's good. If there was a way you could do extra exercises on your own outside the ones that you are giving
Oh,
at home.
okay. Yeah, there's this past. I'll just use the past questions.
Okay,
Questions.
mm, okay, that's good. Okay, that's fine. All right, that works.
Okay. I will send the
All
past
right,
questions to you so
to me. Okay,
we
okay,
can solve it together after
that's
from mine.
that's good. With me. That's good. Okay. All right, now enjoy the rest of your evening.
Thank you, Shanice.